How long could you survive in a black hole, technically? This question is the physics equivalent of asking, how long could I stay alive while being swallowed by a myth? And the answer, unsurprisingly, is, it depends. Mostly on which kind of black hole we're talking about, how close you're willing to get to the speed of light, and how attached you are to your atoms being where you left them. Let's assume, for the sake of giving your hypothetical self a fighting chance, that you're falling feet first into a supermassive black hole, the kind lurking at the centers of galaxies. These are the gentle giants of the black hole world, unlike their smaller, star-mass cousins, which would spaghettify you. Yes, that's the actual technical term physicists use, because nothing screams academic rigor like pasta metaphors. Kilometers above the event horizon, a supermassive black hole is so vast that you could cross the event horizon without even noticing anything particularly strange happening. No sudden lurch, no warning bells, no spaghetti. Just a calm, quiet crossing into the realm of no return. This is the first surprise. Crossing the event horizon doesn't kill you, not immediately. The laws of physics still apply inside it, and locally everything feels normal. Einstein's equivalence principle states that in a small enough region of space-time, gravity is indistinguishable from acceleration. So if you sealed someone in a spaceship and dropped them into a black hole without telling them, they might not realize it until it's far, far too late. But let's not get ahead of ourselves. You're probably wondering, how long do I get to enjoy this gravity-powered sightseeing trip? The short answer is, not long. The long answer is, still not long, but longer than you might think, depending on your definition of alive and you. Once inside the event horizon, all paths lead inward. You can't hover, you can't escape, you can't even not fall further in. Space-time itself is so warped that the singularity isn't just a place in space. It's a moment in your future, like tomorrow or next Tuesday, and nothing can stop you from reaching it. In a typical supermassive black hole like Sagittarius A star, the one at the center of our Milky Way, the journey from the event horizon to the singularity would take a few minutes, maybe 5 to 15, depending on how you fall. Not bad, long enough to reflect on your life choices, short enough that you don't have time to regret them properly. During those minutes, you'd experience something oddly serene. The tidal forces, those gravitational differences that try to stretch you like taffy, are surprisingly weak. Your body wouldn't be torn apart just yet. You'd fall freely, in silence, surrounded by nothing, with the entire universe appearing to blue shift above you into an increasingly bright, distorted patch of sky. Which brings us to the second surprise. Time gets weird. From your perspective, everything outside the black hole appears to speed up. Dramatically. Stars whirl faster. Galaxies spin like CDs on fast forward. The entire universe could play out in front of you like a time-lapse video. Depending on how you interpret the math and how much caffeine your cosmologist has had, you might even witness the eventual heat death of the universe as you descend, although your brain would probably shut down long before you could appreciate that cosmic finale. But from the outside, to an observer watching you fall, things look even stranger. You'd appear to slow down as you approach the event horizon, getting redder and dimmer until you froze in place, a ghostly hologram hovering at the edge of oblivion. Technically, this is a time dilation effect. The closer you get to the event horizon, the more time slows down for you relative to the outside universe. In practice, it just means your family won't have to plan a funeral. They can just say, he's still out there, technically. But let's get back to you. You're still falling, and eventually you reach the singularity. This is the point where physics throws up its hands and says, I don't know, man. Space and time, as we understand them, break down. Densities become infinite. Your atoms are crushed to something smaller than small. There's no known force that can resist this. Even the best helmet won't help. So, how long could you survive? If we define survive as your consciousness remains intact and you're not ripped apart, then the answer is probably about 5 to 15 minutes after crossing the event horizon of a supermassive black hole. Not bad for a trip into a cosmic death trap. If we define it more generously, say, some part of you continues to exist in some form that a very forgiving insurance company might consider alive, Then, depending on quantum effects, maybe longer, maybe forever, maybe never. Some theories suggest information isn't destroyed in black holes, but encoded on the surface, holographically. If true, a version of you may remain, flattened, scrambled, and illegible to anyone but the universe itself. Philosophically, it's comforting to think that no one ever really dies. They just get converted into low-resolution cosmic metadata, technically. So next time you look up at the night sky, remember, somewhere out there, a black hole is waiting to ruin your day slowly and politely. And you'd probably never see it coming, unless you're moving near the speed of light and can read gravitational lensing like a fortune cookie. And in that case, congratulations. You're either a very advanced species or very, very lost.